fraction, when I look at a fraction, I always think about whether are they related by differentiation. Who asked for P? Big one. Okay, so I just look at it, okay? For P, right, the way you look at it is, you look at this as though I'm going to consider the formula I'm going to use, right? I'm going to use f prime x, fx to the power of n. This is everything. Okay, so fx to the power of n. So far, okay? I will. Okay. Okay, so this, right, I will see this as 3 cos 3x multiplied by sine 3x to the power of 2. F prime x, fx to the power. So you can see that this is negative 2, right? I just tested it. Okay, so sorry. Okay. Fx. So far, okay? Can off. So you understand off. Can see a template, can see a metric. So it's quite easy. So it's quite easy. From here, when you integrate, this is supposed after integrate. You integrate, then it's supposed to give you fx to the power of n plus 1 over n plus 1 plus c. So this is fx to the power of n. That will give you fx. This is fx to the power n plus 1. Negative 2 plus 1. That is negative 2. That's negative 1 over n plus 1. Because I can see that straight away, differentiate sine 3x is 3 cos 3x. Life is good. I don't even need to borrow anything. No collaterals. So when I'm integrating this, right, that gives me straight away this answer. This is fx to the power of n plus 1, n plus 1, final answer, plus c. Don't need to write down arbitrary constant. Sorry, come in. How do I differentiate sine 3x? How do I do that? Okay, so if I see this as fx, right, I will see the inside and this is f prime, right? Differentiate sine 3x, you think about chain rule. Also, when we differentiate sine 3x, if I'm thinking about f, if I'm considering like fx, when you differentiate, remember there's an outside function, there's a sine, that will give you cosine 3x. Differentiate inside. Oh, that's chain rule. Okay? So when you're differentiating, all you're doing is you're consider chain rule. Okay, no? Okay, no? For those who need help, look at the solutions. It's in WhatsApp. Okay? Is that okay? See how okay? Okay? How come you are? Answer is different. What did I answer right? Okay, B. My answer is okay also. Science of 191. So this is the same. I mean, sine 3x, right? It's the same as 1 over cosecant. Now, this is the same. If you want to change, it's the same as 1 over cosecant 3x plus c. So, same. So, sine x to the power of negative 1, right, is the same as 1 over sine x. Let me write down here. Sine 3x to the power of negative 1 is the same as 1 over sine 3x, right? It's the same as cosecant 3x. Okay? So from there, type. Which question are you doing now? Which question are you doing now?
I'm doing assignment.
Assignment. Have you done your assignment?
I don't remember. I think I did it before.
Huh?
I did it before.
You did it before?
Yeah.
You brought it here? Then where's the question? You did how much have you done?
About halfway.
Then you show me. Okay.
No, I don't have it with me now.
You don't have your assignment with you now? I don't have.
Yeah, I did it.
Who don't have your assignment with you? Who don't have your assignment? One person. Anyone else? No have, huh? Okay. Just have? Yeah. Okay, what about C? C, okay, C I go through. Okay, so to differentiate C, integrate, sorry. This is the same as integrating secant square x plus secant x tangent x. Very easy one. Okay, you can see sort of just opening up. Of course, when I see a product, what I want to see is whether are they related by differentiation or not. Now look at it, secant times secant, that gives me secant square, secant tangent. Okay. If I integrate secant square, what should I get? I will get tangent x off. So once I integrate already, I don't need to write down, I don't need to write the triangle sign anymore. So I'll check that. Secant tangent, if I integrate secant tangent, what will I get? First sound to ask is Nathaniel. If I integrate secant tangent, what will I get? Secant, very good. Thank you. So that's C. D. Integral of cotangent square 3x minus 5x dx. When you integrate cotangent square, okay, tangent square, you use Pythagorean identity. Okay, so I have no formula for integrating cotangent square, but I can write this as cosecant square gx minus 1. I can write this as 5x. Okay? Integrating cosecant square is easy, right? Integrating cosecant square, what do I get? Cotangent, what? That is negative cotangent. Negative cotangent 3x 1/3. Because I'm borrowing a 3. Right? That's a derivative that you divide by 5. That's it. Okay, so minus 1 integrate minus x. 5x, 5x square over 2 plus c. That's all. Okay? Sorry. That's D. Which one do you not connect? Middle line, middle line. Cotangent square is the same as cosecant square minus 1. Why? Pythagorean identity. No. Yeah, Pythagorean. Okay. Do you remember you see tangent square plus 1 is secant square. Sine square plus cos square is 1. Cotangent square plus 1 is cosecant square. So therefore, based on this, can I also say that cotangent square is the same as cosecant square x minus 1? Seem okay, right? So this is called the Pythagorean identity. Why change the? Why do I change? Why do I change from here to here? Okay, the reason is because we have no way of integrating cotangent square. Okay, so when there's no way to integrate cotangent square, what we do is we change it using another method. Okay, we change using another method into something that we can integrate. And I can bet you $5. If you are integrating a trigo likelihood, there are some tricks up. There are some tricks that you need to do. The double angle, Pythagorean. Okay, or f prime over fx, right? And GC stuff. We never give you anything direct on time.
It changes back to potential again.
Because this is from formula. When I integrate cosecant square, I get potential. So from here to here, right? From here to here is not integration of. Here is just Pythagorean identity. Here to here, this is Pythagorean identity. Because I have no formula for integrating cotangent square. I change cotangent square to cosecant square, 3x minus 1. So this part is this part.
So where did the 1/3 come from?
Where did the 1/3 come from? It's because, okay, remember, the formula is this. When I integrate f prime, okay, x cosecant square fx dx, this gives me minus tangent fx plus c. Is this okay for you? Is this okay for you? It's okay for you? No, okay? When I differentiate cotangent fx, differentiate cotangent is what? What can I ask? Differentiate cotangent, what can I get? Anything about co? Negative cosecant square fx. Okay? Let's say I put yeah. So let's say if I integrate this one. Sorry, what else? That's all? Then when you integrate the inside, there's also an f prime, right? There's also an f prime, right? Agree? If I differentiate this, I get this one. So does it also mean that when I integrate this, the negative sign goes over? Is this okay? Is it okay now? Where did you park it? So the 1/3 is this one. The 1/3 is this. Okay, so I integrate. So first you must buy this formula first. You buy this formula. Do you buy this? Alright, so doing sales is like that, ma. First I sell you the table. Then after I sell you the table, I'll say, actually you also need to buy chair. Okay, so I sell the table first. Now you see, you integrate cosecant square 3x dx. Now you look at this formula. You got a table or you got a chair or not? You have f prime. Have or not? The question, don't have how? Buy lah. Okay, so you say I borrow You see carefully you see. Look at the board If you do somewhere else, I'll throw a softball at you. Okay, so this is 3 now outside. Can I put a 1/3? This one is f prime. That is the f prime. That's where it comes from. So when I integrate this part, when I integrate this part, this is the part that gives me cotangent 3x negative. So the 1/3 is borrowed. Okay, ma? So you must have the formulas in your head. Otherwise, it's like always ground zero. It's always ground zero. It's very hard to start. Always have the formula somewhere. Personally, at home, I put it on my wall. I decorate my toilet wall with formulas. I see it every day. Okay? Can I? Shall I okay? Can I? Okay, all okay, ma? You see? Okay, I'm good. Okay. If you don't buy the formula, you tell me I sell you and something else. Yeah.
So the identity for cosecant to tangent is like negative cosecant, right? But then, so we can just like...
The minus sign can move around. Can move both sides. Off. Differentiate cotangent x gives you negative cosecant square. Differentiate negative cotangent x. Just cosecant x off. The cosecant, the negative sign can move around. Just like chemistry, that's negative. Okay. Okay, so D is done. You all buy it? All buy? Yeah, you don't pay attention never mind, you must buy my formula, okay? Okay. You buy, okay, E, let's go at E. E is so easy, right? E is so easy. Who asked for E? Hong Sun. Okay, so E, none other than our favorite formula, which is just we are integrating f prime x e to the power fx. Such a beautiful and nice formula. So this is the formula that we integrate. Yeah, let me use markers then. So sine 2x e so this one, can you see this is f, if I treat this as fx, okay, now you are at this level where you must differentiate this in your head. Okay, what will this be? If you imagine this as fx, if fx is cosine x squared, what do you differentiate? When you differentiate cosine x, what will you get? Okay, Masha, differentiate what will you get? Differentiate outside, I'll get 2 cosine. Differentiate outside this one. Differentiate inside. Huh? Differentiate cosine will be sine. Sine. Only sine. Only sine. Negative sine. Oh, negative sine. Okay, ma? 2 cos x sine x. What do you see? 2 cos x sine x. What do you see? Yes. Right, everything looks cool when it's double, just like McSpicy, right? So minus 2 sine x cos x off. Yeah, so okay, can you see? If this is my fx, my f prime needs to be this. I have it here. I have it here. Now this one is like your this boy that likes you secretly is been waiting for you. Alright? Okay? Just put a minus sign here. This is none other than the f prime who has been waiting for you like a lawyer pet. Okay? Look at f prime e power. But not lawyer pet or royal pet. Royal pet. Okay, so this one is just e cosine square x plus c. Negative sign, negative sign. Okay? I just go by formula, that's all. Okay, I just go by formula. In the sense, this part requires us to be like a machine. Okay. F, who wants for F? Okay, F is very sickening. Also, F is very hard. Oh. Not secant, not the secant function, but this one is okay. In integration, then what I'll do is I will treat everything as index form. Like that, okay, then I see, I change them all to square root. Okay, this is where the trick is, can you see? I bring this up. Can you see? Okay, the x goes up, become negative half. No, okay, one more time, Okay, 1 over square root x, can I say the same as 1 over x power half is the same as x power negative half? Yes, correct. So I'm going to bring that square root x, I'm going to bring this up. I'm going to bring this up, okay? So it's going to be x power negative half. Yes. Half inside, half inside. Okay, so now you see, you look at this too. Remember I asked you when you look at integration is like you're paying back karma. There must always be an f prime there. Yeah. Okay. So for f, okay. Great. 2 over 1 plus square root x power x, right? Okay. Okay. So it's good for the camera. So this one will go up. This will go up, okay? This will go up. This is the same as x power half. This is the same as x power half, okay? This one goes up, this one goes up, see? This goes up, becomes x power minus half, okay? So far comfortable? Comfortable. Now, the next part, now you look at these two. How do you think they are related? Can you see? In a way, when you do differentiation in your head, this is fx, this one must be f prime. Power half, power negative half. Okay? So, if I differentiate the bottom, my top needs to look like this. So I put a 2 outside. If I need a half here, outside I'll put a maybe 4. 2 times 1 is the same as 4 times half. So can you see what I created here? The product is 2. So at first it's like this, right? At first it's like this, right? There's 2, right? First like this, right? I need a half here for f prime. Here I need a half here. So it's like whatever I borrow inside, outside I return the reciprocal. It's like 1 over half, which is 2. 1 over half. Whatever I borrow inside, outside I return the reciprocal. Okay. So in the sense this is like 4. So beautiful, look at this. Wow, this is like again, the f prime x is sitting there, the lawyer pad waiting for us, right? So this is f prime, this is fx. So integrate f prime over fx, what do I get? The person of the ask is Ashita. Name me a boy in the class. Oh, okay. Name me any student in the class. Sorry? Freedom. Oh. Okay, so f prime over fx, what do I get? Log, very good. Also, this is just for okay. Log 1 plus square root x plus c. Beautiful? Okay.
You don't need to mod it.
Sorry?
You don't need the mod.
Oh, can because 1 plus square is guaranteed to be positive. So you can mod, you can also do mod. Square root x is always more than 0. Then plus 1. So you don't have to mod. If you want to mod, cannot. You see cannot. Cannot. From here to here, I lost you. Okay. Now you see, okay, this part, right? Okay, you see carefully, Can I bring this on top? Okay, can I do that? Oh, cannot. I mean, that will help me at the f prime. Okay, so that's what I'll do. Okay. Can I call this power half? Power half? I write this. Cannot. This is x to the power of negative half. This, right? Look at this as f prime. Look at this as fx. Okay, so okay. You see, okay, what I'm going to do is the formula I'm using is when I integrate f prime x over fx, that will give me ln of modulus fx plus. So I want you to see this as fx and this as f prime. Okay? See, okay, I bring the 2 out. So from here, I'm going to jump to here. Okay? Can you see that this is what I have now? From here, I put the 2 outside. Cannot? I show you. This one I brought on top. This one I brought on top. See this one I brought on top. Now it's here. Sorry? Why do I take the 2 out, is it? Why do I take the 2 out? Okay, you don't take the 2 out also can leave it inside. You don't take it out. This one is fine. I just take out because in integration, scalar multiple do make it happy. integration, scalar multiples not so important. It can happen outside. Yeah. Yeah. So I pull out again. Okay. If this is fx, differentiate 1 is 0. Differentiate x power half is half x to the power negative 1 times. Let's say if you differentiate 1 plus x power half, this is 0 plus half x to the power negative half. Can I? So on top, you see I need a half. And outside I multiply by 1 over half. This is 4. This is f prime over fx. Okay, that's 4. Yeah. Okay. The half here, right? The half here is so because when I borrow a half here outside, I divide by the reciprocal. Okay, so for example, if I need a 3 here, outside I put 1 over 3. When I put half here, outside I divide 1 over half, which is 2 lah. Because why do I need this half? Because when I differentiate this, right, I need a half as the f prime. I need a half for f prime x. Yeah. Okay, no? Yeah, no? Okay, so I'm done with question 1. Okay. So 2C, yeah. I only have 2. Okay, so 2C, yeah. Oh. See one extent of one. Okay, so. Okay, ready, yeah? If I go through, you try to listen 10. So if you don't understand, you just give me the kimchi look and which then I will understand. Okay? So 做没错 I will understand. But try to pay attention. Yeah. Try not to ask me a question that somebody else asked and I also asked. Okay, so this one, this is the same as the integral of 7 to 3 fx dx minus integral 7 to 3 2x dx. So you see, take a look. Okay, the 2 my personal habit is I like to put outside. So I like to put the 2 outside. Scalar multiples not really important, right? So then how do I find 7 to 3? 3 to 7 fx there? Is it just here? Yeah, it's just here. 6, okay. Then what is this? Integral. Yeah, so nice, right? Integrate x is just half x squared from 3 to 7. So when I integrate this, x, it just gives me half x squared over 2. Then this is 6 minus 2, half of 7 squared, half of 3 squared. What's that half? What's that half? This one is okay. When you integrate x to the power of n dx, this will give you x to the power of n plus 1 over n plus 1. So if I integrate here, if I integrate x to the power of 1, x to the power of 2 over 2. Okay, cannot. So 6 minus 2. This one is 49 over 2. This one is 9 over 2. What's 49 minus 9 over 2? 49 over 2 minus 9 over 2. Sorry? Able to tell me, Sherry? 49 minus 9? 40 over 2? So it's just 6 minus 40. And the answer is negative 34. So that's 2C. Who asked for 2C? Do I have your attention? Who asked for 2C? Do I have you? Okay, if it doesn't sell to you, let me know. Okay, what primary school are you from? Bloody Mas. Breakfast. Can. Okay, next one, question 3. Question 3, who asked for question 3? Question 3 is so nice. It's perfectly built for you, right? Yeah, it's just an f prime x over fx. If you look at this as fx, right? It's like that, right? It's like that. One day when you're about to get married, then you start to look around for a wife. Also, when it's fx, of variable age, then I just look for a girlfriend. Now that you're fx, right, you're all old and mature already, right, which is start to look for an f prime. Who's the f prime? When you're fx, your husband is f prime. Differentiate x. What? The one on top. Differentiate cosine. So your f prime has all along been waiting for you. No? Cannot. So once you differentiate it, it's log of x plus cos x. Okay? Then very nice, beautiful. Okay, this is the best question. Can I? Okay, I just pause a while. Sure, okay? In every question, I always try to see that there are two functions, right, that can be related by differentiation. F prime, fx, f prime, fx. So that's what I think about. Question 4. So question 4. Okay. Question 4, part 1. Yeah. Because I think last question really quite easy. Okay, so no. Revise. No, I think last question is those kind that you do. I send you a video. I revise one. It's quite we'll make it up very fast. Okay. So this is partial fraction. You show this one, right? Okay. After that, so yeah, 1 year ago, right? We always ask ourselves, hey Jeffrey, why I go and learn partial fraction for one? No use. So remember 1 year ago I tell you, hey, next 1 year from now, when you learn integration, it's damn useful. So this is where it's useful. Okay. So this one, right, is the same as this. 1 over 5x plus 1. Okay, Can you go? Okay, so from here, if I integrate this, what do I get? This is the same as me integrating this. I just put a 2 over 5 outside. This is 1 over 2x minus 3 minus 1 over 5 integral of 1 over x plus 1. Such a beautiful and sexy function. 1 over something. Integrate, what do we get? 3. What do I get? What comes to your mind? Do you again see f prime over fx? Do you see f prime over fx again? If this is fx, what is my f prime? Cancel away. This one already f prime over fx. So when you integrate straight away, it's just 1 over 5 ln 2x minus 3 minus ln x plus 1. Okay, sub in 3, sub in 6, and you will get your answer. Okay, ma? No shouting? Cheryl, okay? Our okay? Lindsay? Love? Can I? Sasha? Oh, good. Okay. Question 4 time. Question 5. Question 5. else for question 5? Okay. Only one person? The rest you? Okay. Who did not do question 5? Okay. I go through okay. So I go through, I will look at our, if you never do, you know what I'll do, right? I will look at you for information. So when I look at you, you know your head, then I know that I can go on. Okay? So if you give me a blank look, then I will say a bit more. Okay? So the game plan is this, from d to 1 dx squared. If I want to find the equation of the curve, right, I first need to integrate one time. After I integrate one time, I will get a dy dx plus c. Okay? After that, I can integrate another time. Cool, we show pay attention. You look like you're surfing TikTok like that. Okay. Integrate another time, I'll get y plus cx plus d. So when I integrate dy dx, I will get y. Okay, man? When I integrate c second time, I will get cx plus d. So going all the way from d to 1 dx squared up to y, you will have two arbitrary constant. You have two arbitrary constant. Okay? Sorry? Y got y. Y is the equation of the curve. So I integrate d to 1 dx squared, right? This one is 36x squared. Okay? If I integrate one time, I will get 12x cubed plus c. Now integrate next time, I will have x power 4, 3x power 4 plus cx plus d. Okay? So this is dy dx. Okay, man? Okay? You know, okay? Why is it y? Why is it y? Yeah, the y equal, you get the expression for y plus the cx plus d. I mean, dy dx, you get y. That's very loosely, very loosely. Okay, man? So, what do you do is you want to find probability, right? This is y equals to this, right? Y equals to this. This is dy dx equals to this. This is what you get. And this is 2y dx squared. So this is your equation. Y equals to 3x power 4 plus cx plus d, right? It has a turning point at -1, -9. Okay, you sub in, okay, from here, and x equals to -1, your y is equals to -9, and your dy dx is also equals to 0, because they say there's a turning point. Okay, our here, slow down. It has a turning point. It means to tell you that at this point, your dy dx is 0. Okay, your dy dx is 0. Why is it at the middle one? Why is it at this one? Oh, so what I'm doing is I'm finding the c first. That's why I use the middle one. I'm finding the c first. From d to 1 dx squared, if I integrate one time, I'll get an arbitrary constant. If I integrate one time, will I get arbitrary constant? I'll get 1, right? So let's find what this c is. Is it okay? Yeah, okay, so you all see, okay. First of all, let me show you the steps. My d to 1 dx squared given by the question is 36x squared. If I integrate one time, I'm going to get dy dx. Am I right? Then I will get, okay, so integrate this one, 36x power 3 divided by 3 plus c. That gives me 12x cubed plus c. Is that okay? Question tell you, turning point, x equal -1, y equal -9. Turning point means what? Your dy dx is 0. Okay, 0. You say 0? You say 0? No, you say 0. 是开. Turning point, dy dx is 0. 是开. It's 是开. Turning point, dy dx is 新会. Turning point, dy dx is 0. Okay, and so that x equals to -1, your dy dx is 0. I sub these 2 points in, okay? So I sub this one as 0. I sub this as -1. Okay, so 0 is -12 plus c. C is just equals to 12. Such a nice and beautiful constant. Once you know this, right, as of now, you will know that your dy dx is equals to 12x cubed plus 12. That is what you have. Is that okay? All turning points are divided to 0. Yes, correct. All turning points divided. Divide direct equals to 0 doesn't mean turning point. It can also mean point fraction. So if your divide dx equals to 0, right, it can mean 3 things. One, maximum point. Correct. Minimum. Or point fraction. Point fraction, right? Yes. Correct. It's not equivalent. So from here, after that, how do I find the equation of the curve? I integrate this one more time. Squeeze your body and say integrate one more time. 这哪一个叫游戏 ？One more time. Okay. Okay. One more time. So here, integrate again. Integrate y is equals to integrate 12x cubed plus c. You get 3x power 4. This one 12x to the power of 4 over 4 plus 12. Sorry, this is 12. X plus d. One more time, one more arbitrary constant. Okay, write down this. So simplify this. 12 over 4 is 3. 3x power 4 plus 12x plus d. So y. From here, sub in x equals to -1, y equals to -9. Why? Did someone say why? Did someone say why? No. Huh? Why? Why do I do that? Because I want to find the arbitrary constant. Okay? I want to find the arbitrary constant. Does everyone buy this? Anyone doesn't want to buy my idea? Let me sell you something else. You see? Buy. Okay. After you suck in already, fast forward, you will get y equals to, write down please. Yeah, you get d equals to 0. So life is great. D is just 0. Okay. So your y is just equal to 3x4 plus 12x, and you are done. You have answered the question, the equation of the curve done. 5 marks in your pocket. Show that there are no turning points. Show that there are no other turning points on the curve. How do I do this? When you think of turning points, what comes to your mind? What's the? I want to ask Zi or Zi. Okay, I want to ask Hong Sun. When you think of turning point, what's the first thing that comes to your mind? When you think of turning point, finding turning points. When you think of finding turning point. Quality equation has turning point. There are also many curves that have turning point. What you think about? Think differentiation. Yeah, okay, again. Today I'm talking about differentiation. Okay, so when you think about turning point, people ask you go and find a turning point, what will you do? Yeah, you equals 0. Discriminant. You think you get discriminated. Okay, so dy dx equals 0. Oh, fair enough. to show that no turning point, right? Turning point, okay. Your dy dx is 12x cubed plus 12, right? You want to show that when you equate this to 0, there's only one answer. There's only one answer. Owen, how many answer? One answer. Okay, oh? So very easy, lor, this here. Equate this to negative 12, x equals to negative 1. Only one answer. This is the one and only answer. No more already. Okay? Because if you divide by 12 on both sides, x cubed is negative 1. Therefore, it's negative 1. Both are okay. I didn't use the screw. Yeah. You see okay, man?
Yes.
Yes, fine. You buy? Our okay? Between okay? Critical okay? Okay. With that, I'm done. I finished one. Okay, so anyone still have question for assignment? If you are good, for the last 4 minutes, I have something very, very important for you to do. Listen carefully, this is not trivial, this is a very important matter. Okay, you want to upload your assignment. Upload now. Upload and show me save entry before I leave my cooking. If you never show me, you cannot leave today. Yeah, okay, thank you. Upload already? Upload already? So far, I see the submission rate very good, 5 upon 25. Okay, ready? Okay, can I solve do that? This is what I saw between okay, that's all. Okay, that's all. Thank you, class.